Yeah, Craig, we've got just a few of the newspaper articles that keep grabbing as we walk up and down the halls and the sidewalks of the discussion of this Zika virus. People are very frightened. In fact, you may remember a time when there was another virus on the horizon that had this kind of public worry. There are all the issues about birth defects and how it spreads, and I think we're seeing quite a phenomenon here. So we thought it'd be useful in the MOOC, have a little bit of a discussion on it as an emerging disease and talk about where it came from, what kind of bug this is, and what the ramifications are for future history as this thing begins to unfold. So, Craig, first of all, why don't you talk to us a little bit about this virus? What is it? Where does it fit into the scheme of things? And
this virus is one of a part of a family of viruses that virologists call the flaviviruses. And these viruses are well known among medical personnel. Yellow fever, which we've talked a lot about in this course and how it affected history, and dengue fever, which even today is really an endemic problem in a lot of tropical countries, and even Japanese encephalitis. This virus is in that group, and when it was discovered in 1947, was thought to be inconsequential. There are other viruses in this group that are kind of inconsequential compared to those three. But now we know that maybe that's not the case. Well-documented outbreaks of this virus as early as 1968 in Africa, and then over in parts of the Pacific, Yap Island and French Polynesia as little as 2 years ago. So it's been on the horizon, but probably just hasn't captivated our interest. But there is one thing that's really interesting about this virus, I think, and that's the fact that it's an RNA virus. Anytime as a microbiologist you see an RNA virus, you know one thing: the mutation rate is going to be a lot higher. So the possibility of this organism evolving rapidly to become highly pathogenic or to change transmission routes is there.
And could I ask you a little bit about that, Craig? I think a lot of the concern that's out there, as I read it, has to do with the notion that, well, it isn't just this Aedes aegypti mosquito, but it's also sex, it's blood transfusion, maybe even kissing, bodily fluids. Is this an evolutionary mutation kind of thing that may be happening here that makes this virus maybe a little more frightening than, say, even yellow fever or dengue or chikungunya?
Yeah, I think you're onto something there, Gene. We've seen this occasionally with other organisms. You know, we told the story of syphilis perhaps adapting from a skin infection to one that's sexually transmitted. I suspect with this virus, like some of the other viruses, including HIV, it's a blood-borne virus, but there are multiple routes that it can be transmitted. HIV, although in the blood, can also be found in the semen and vaginal secretions. And you know, it's hard to say with this right now. The data's preliminary, but it's enticing, at least to molecular biologists and epidemiologists, to say maybe it's evolving and adapting to being transmitted in other ways. So it's a little early in the game, but I think of all the transmission routes that we look at, probably the one that will get scrutinized right now the most is whether it can cross the placenta and infect the fetus. Now, none of the other flaviviruses do this currently. They're usually newborns contract them as they slide down the birth canal of an infected mother. So I think of these transmission routes, that one's got to be drawing a lot of attention right now.
And back to the mosquito, somebody said wisely and accurately that the mosquito is the most dangerous animal on the planet, has murdered millions and millions and millions of people, as we've seen in this course. As we look at this bug, the fear factor from this bug is that it breeds in such tiny places. It has adapted entirely to the human population, whereas many mosquitoes infect animals as well as humans. This is a human mosquito. It lives only where humans live. It lives in very restricted places where urban populations are. Makes it a little more frightening in terms of the science involved in this to begin to deal with this mosquito.
Well, that's exactly right. Aedes aegypti, the mosquito that transmit this, is I kind of think of it like a raccoon or a coyote or the white-tailed deer or whatever. It's over time, it's adapted to living around humans in small pots of water, Some studies have indicated as small as an upturned cap off a pop bottle can hold enough water for this mosquito to breed. And so you're right. The one thing the only valuable thing about this mosquito is it's not very good at surviving in temperate environments. But then that brings in the next question, which is particularly in the United States, where we had since about 1980 an invasion of the Asian tiger mosquito, a different species of mosquito, but can live in temperate environments and has the possibility to carry some of these diseases, chikungunya virus being one of the examples. And I think that's also on the horizon. Will this virus mutate and adapt to a more temperate mosquito? This mosquito is found in 30 states, all up the eastern seaboard, and wow, that would make a lot more headlines than what we've got here right now.
Yeah, and to speak about that just a little bit more, if we want to think about the subject of our course, which is how disease affects people, how about the abortion situation, where you have in places like Brazil literally thousands and thousands of women who might not have thought about having an abortion before are now going to demand to have an abortion. So that whole issue, that whole set of moral constructs that we debate over and over again begins to take on a new flavor when you have to deal with the very real possibility of this disease-causing birth defect. Would you talk a little bit about that aspect of this particular disease? What do we know about it? Is this fear accurate, or is it a little ahead of the game, or what do we know about that issue?
Well, there's two ways to really look at what happens, and one is to actually have the biology in front of you where you've proved everything in animal models or you have really good human data, and the other one is to use epidemiological data. And that's where we're at right now. We're in kind of the early phase of this. There's this microcephaly that's been going on, explosion of this. Looks like the Zika virus came at the same time. You've got 4,000 cases of this observed in Brazil, 4 million cases of Zika virus. And so I think we're relying on the epidemiological investigations right now, and that still has to be proved with the molecular biology, but it's compelling, and we certainly had a lot of other stories that have been generated by epidemiological observations to begin with, including HIV, where that story began that way, and Lyme disease. So there's still work to be done, that's for sure, but and Guillain-Barré, now all of a sudden that's beginning to bubble up, that there are an unusual number of cases of that. And this is a really strong explanation, that's for sure.
So perhaps much of this fear is misplaced, but on the other hand, perhaps it's the opening to what we'll discover to be very much a causal factor in these awful situations. And talk about the normal course of this Zika infection. We worry about the birth defects and we worry about this and that, but what's the normal course of this if you get it?
So for most people, I think that's been the thing that's created kind of the laissez-faire, when it was first discovered about a year ago. And that's because for most people, it's a lot like West Nile virus. Here's a virus that for most people who catch it in a good state of health, they acquire the virus and the symptoms are mild or maybe even inapparent. And the Zika virus, over the course of time has appeared this way. Although early tests, when you had this, if you had a severe case, would cross-react with the dengue fever virus, and maybe, the more severe strains of this got misdiagnosed. But for most of us, not too big of a deal. But it can go into the lymph nodes. It can go into the bloodstream. That's where you're going to have to look for this placental transfer, because maternal blood goes through the fetus. And so
one last issue, and that has to do with, we talk about emerging diseases. Last year it was chikungunya, this year it's Zika. What do you see in the future? It just seems like because of the science you guys are able to do, we're becoming much more aware of these things. And as you say, sometimes we didn't even realize this stuff was around. What do you see down the road as we think about Zika and chikungunya, and what else is going to hit us?
Well, I think Zika is a pretty good example. It's been on our radar for almost 60 years and even maybe 40 years, knowing it's in the human population. And although I don't have a list in front of me, I imagine there are a lot of these viruses that have had incidental contact with humans. And so, as we've talked about, populations, poverty, mosquito transmission, it's hard to predict. I mean, we thought everybody in the community took a sigh of relief when the Ebola subsided and when chikungunya, we started to get that under control. And then, almost immediately, within a month or two, Zika virus shows up. So we're just going to have to be constantly vigilant.
What about vaccine?
So that's kind of interesting, too. There's been a lot of talk about a vaccine, and if you look at the other diseases caused by flaviviruses, of course, the one that jumps out is yellow fever, and we have had a yellow fever vaccine, but it's not a great vaccine. It's been effective, but not super effective. We don't have a vaccine for dengue fever, Japanese encephalitis, and so I think people talk vaccine, but when you really look at the articles by those in the health community, they say maybe some years before we get a very effective vaccine. So I think we're going to have to go to what's really worked for yellow fever and dengue fever, and that's vector control, and that's controlling mosquito populations. And as you mentioned, that is challenging in many parts of the world.
Very difficult. We've talked about how the Panama Canal was built on mosquito abatement. Maybe that's the answer that we have here. The only really good answer is mosquito abatement. This is a tough bug to deal with, though, isn't it? Because of the way it lives and where it can live.
Oh, yeah. Yeah, it's going to be challenging, you look at countries, back when DDT could be utilized, and now we know the ecological consequences of it, the malaria was gone in many countries, and now because of that, it's back, and we have to look at other things. I think one of the interesting aspects of Zika that we might not think about is the fact that in the last year or two, we've used bred, genetically modified mosquitoes that have what we call gene drive, the capacity to push into an entire mosquito population, the ability to be ineffective in breeding. And this might just tip over gene-modified release of insects. It's already going on in Brazil right now. And so I think, creative solutions might be called for, and this might be the thing that pushes them forward.